something else came across my desk, which was very interesting because we like water here at the Vacuous Perspective.
We do. Yes.
We've talked about water quite a lot. And
you got to be kind to yourself.
Why?
Well, you are water as well, right?
Oh, yes.
Kind. What is it? Some sort of percentage of you is water. It's very high.
Very high. Yeah, I think it's like 70.
Yeah.
Sound about right?
It's a lot.
It seems unusually high though, doesn't it?
I've never seen any.
Like we are a little bit squishy.
Yeah? Are you? Yeah, a little bit.
But not like a water balloon. So, University College of London.
Yes. What are they up to?
Actually, it's just called University College London. I don't know.
Right.
So there's some researchers.
UCL. Yeah, UCL.
UCL. There's some researchers at UCL.
Yeah.
And University of Cambridge. They're working together in a collab.
Yep.
They've discovered a new type of ice that more closely resembles liquid water than any other known ices.
I'm confused. Is it just water, really cold?
That's what I thought. That's what I thought. But they say, this is what got me going. In the first line, they said, this might rewrite our understanding of water and its many anomalies. And I thought, okay, so this newly discovered ice is amorphous. That is, its molecules are in a disorganized form, not neatly ordered as they are in ordinary crystalline ice. Still sounds like water, right?
Yeah, it still sounds like water.
Still sounds like water. At some point, you might say it doesn't sound like water. Maybe you'll just keep being water. Amorphous, cold water, very cold. Amorphous ice, although rare on Earth, is the main type of ice found in space. That is because in the colder environment of space, ice does not have enough thermal energy to form crystals. Still sounds like cold water. You let me know when it doesn't sound like cold water.
Space cold water. Yeah.
Cold water in space. So they found that. So what they did is they put it all they put metal ball bearings. They super chilled it and they kept shaking it with metal ball bearings in it so the crystalline ice structure can't form. So they say this novel amorphous form of ice that, unlike other all-known ices, had the same density as liquid water.
Right.
And whose state resembled water in solid form. Still sounds like water. Still sounds like water.
Something resembles water. Yeah, it is water, by the way. It's just in a different state, right?
And they've named this new ice medium density amorphous ice, or MDA.
So there was large density Morpheus ice and there was low density Morpheus ice, and now we've invented a new one, which is, say it again,
a medium density amorphous ice.
Amorphous ice.
Happy medium.
And but we don't see because they say it's generally in space. We don't come across it very much on the planet. What's going on? Where's all this amorphous ice going?
Okay, so it looks like fine white powder, and it may exist inside ice moons of the outer solar system.
What do you mean it may? Isn't it on Earth? Haven't we got some?
We had to go through a whole process to make it for the first time here.
We made it here.
We made it here.
We made space ice.
We made space ice. Terrestrial space ice.
Right. What are we up to down here?
So in addition, the team found that when MDA, sounds like it's a fine white powder called MDA, sounds like a drug to me.
It does.
When it was warmed up and recrystallized, it released an extraordinary amount of heat.
What?
Mean it could trigger tectonic motions and ice quakes in the kilometers thick covering of ice moons, of ice on moons such as Jupiter's Ganymede.
So Ganymede's got some ice mountains and they could be subject to this kind of amorphous activity?
Well, yeah, it's like tectonic. There could be...
And it would release heat, which would melt ice, which would...
cause ice quakes, and it's geologically active, potentially. Somewhat.
Why is it going to change our understanding of water? Is that the changing of our understanding?
I don't know.
I didn't know that water could cause like through that, releasing heat energy. That's pretty fresh.
It sounds weird, doesn't it? Because it's super cold ice and all of a sudden it's releasing huge amounts of heat.
Yes.
But that's the recrystallization. When you start warming it up, it starts recrystallising. Right. And
so what are we doing?
It's ice water is in a high energy state, even though it's super cold. So this senior professor says, water is the foundation of all life. Our existence depends on it. We launch space missions searching for it, yet from a scientific point of view, it is poorly understood. We know of 20 crystalline forms of ice, but only 2 main types of amorphous ice have previously been discovered, known as high-density and low-density amorphous ices.
Are you fucking joking me?
No, there is.
What? Stop! I was joking. I didn't look any of this shit up. I was like, they had high density, they had low density. Now they just need medium density. I was joking.
You should be the scientist.
Oh no!
It made sense though, right? So there's a huge density gap. There is a huge density gap between them. And the accepted wisdom has been that no ice exists within that density gap.
Wow, so it's low, high, or nothing.
That's it. And their study shows...
we've got medium.
We have medium. Their study shows that the density of MDA is precisely within this density gap. And this finding may have far-reaching consequences for our understanding of liquid water and its many anomalies.
What are these other anomalies that I'm not aware of those?
Water's quite unusual. For example, as it gets colder, it becomes less dense between 4 and 0 degrees. So normally as things become colder, they contract, and then therefore they become denser and they sink. If you have, like, for example, a solid form of any other substance will sink in a liquid form of it, but ice water floats.
Amazing. Why?
Because it's less dense.
Preserves some density.
It's less dense as it forms the crystalline structure.
Yes.
To form that, the molecules are more expanded in their like lattice than they are when they're in liquid form. So
I'm starting to think that we need to start worrying about water. Not the water in the dams or, that sort of water.
It's very sneaky. It's very
sneaky. That's what I'm saying. Yeah, it got into 70% or above of us. It infiltrated. It evolved. To be used in icy drinks. It wants to be at the parties. It wants to be chucked in the esky.
We don't know what it's up to.
We're working for it. It's not working for us.
We can't figure it out.
Well, I think it's scared now because we are figuring it out. We know about medium density amorphous ice now.
Well, the density gap between the known amorphous ices has led scientists to suggest water, in fact, exists as 2 liquids at very cold temperatures, and that theoretically, at a certain temperature, both of these liquids could coexist, with one type floating above the other, as when mixing oil and water.
Amazing. Okay, so you got water on water. Is it water on water?
Yeah. So
that's kind of fun. Yeah,
this professor said existing models of water should be retested. So we don't trust it. He does not trust it.
Get rid of them. Get rid of them as far as I'm concerned.
They need to be able to explain the existence of medium density amorphous ice. This should be the starting point for finally explaining liquid water.
And I would, I know these episodes get out a bit late, but I wouldn't be drinking any water until the results come in.
That sounds like wise advice from you.
Just in case.
That could be the smartest thing you've ever said.
Just in case. I'm drinking a vanilla Coke.
Yeah, I'll stick with I've got a Sunkist actually. So stick with the Sunkist. Stick with ultra-processed foods until...
Yes, until we hear that, until we know about water.
Until we know whether water's safe or not, we'd better stick with ultra-processed.
Yeah. Haven't you already had enough?
Oh shit, there's an ice block in this.
Okay, here we go. Nah, I think it evolved to I think it wants to be in those drinks. I think it loves it. It floats. That's an evolutionary trait.
It's a survival mechanism.
Exactly. Anything it can do.
Yeah, so I thought that was interesting because I thought we had figured water out.
Oh, I thought we would have figured water out by now. Yeah. But apparently
we've got no idea. No idea what it's doing on space or on Earth. Now we're confused about
when we will. We know about this medium density stuff now, so boom.